2.3, we have two rules that we're going to focus on. What if we have a product where both pieces are variables? We've looked in a previous section where we had a constant times a function. What if we have a function times a function? So if we have a function times a function and we want to take the derivative, it's not just so simple as take the derivative of each function. If we have something with a variable times something with a variable, we have to take the derivative of the first function times the second plus the first function times the derivative of the second. So we do take the derivative of each of them, but it's not just the derivative of the first times the derivative of the second. So sometimes this rule is shortened, and instead of using function notation, we say, let's suppose we have u and v, where both of those are variables, or functions of x. We take the derivative of the first part times the second, plus the first times the derivative of the second. So if this is one function, take the derivative of it times the other one, and then take the derivative of the other function times the first. So in this case, we have something with a variable times something with a variable, so we could call it x to the third u. So the derivative of that, 3 down x to the 1 less power. Call the second part. And the derivative of that, the derivative of cosine, is minus sine. It's the derivative of the first times the second. So this is u prime v plus u times v prime. So u is x cubed, v prime is negative sine x. So we could write that as 3x squared cosine x. A positive times a negative would make that minus x cubed times sine x. So u prime v, u v prime. Now remember, order doesn't matter as long as we have the derivative of one of them and times the other one, and then in the opposite order. So we might have had this here and this there, as long as we end up with that term and that term. So that's our product rule. That's how that works. Our other rule is a quotient. So if we have a quotient that we want to take the derivative of, I'm going to use the u and v notation instead of our function notation. So to take this derivative, it's the derivative of the top times the bottom. Sounds familiar? Sounds kind of like the product rule. And then it's the top times the derivative of the bottom. But instead of plus, like we have with a product rule, since it's a quotient, we have a minus. And we put all of that over the denominator squared. So if we use that rule, here we have a quotient. So if we call this u and this v, we need to know u prime. So the derivative of u is minus sine t. And we need to know v prime. So if this is v, the derivative of that is 3t to the 1 less power. So the derivative of our function overall is the derivative of the top times the bottom minus the top times the derivative of the bottom. Put all of that over the denominator squared. So this is just simply u prime v minus u times v prime over v squared. So that's just our quotient rule formula. Now we just need to do some simplifying. So notice that the terms on top both have at least a t squared in them. So we could factor out a t to the second. So the first term, if we take a t to the second out, we're left with a t and a minus sine t. So t times minus sine t, we could call that negative t times sine t. Negative times positive is negative. Sine t times the remaining t, if we take two of those out, t times sine t or sine t times t. If we take t squared out here, we're left with a 3 and the cosine t. Now you could have also taken a negative out, and that would make both of those positive. That's up to you. On the bottom, we have something with a power. That's raised to a power, so multiply those exponents. And then we could reduce here. We could cancel these two with two of those. And that would be minus t times sine t minus 3 cosine t over t to the fourth. And other than taking a negative out, there's nothing else we could do to simplify that. No common factors on top. No like terms to combine. So that's as far as we can go. That's our derivative of that quotient. All right, here we have another one that's a product. So we could call this part u and that part v. So if u is t to the 7th, u prime is 7t to the 6th, 7 down t to the 1 less power. If v is sine, then v prime is the derivative of sine, which is cosine. Product rule is u prime v plus u v prime. So in place of u prime, that's 7t to the 6th. In place of v, that's sine. U is t to the 7th, v prime is cosine. That's fine like that, or we can factor. Both terms have at least t to the 6th in them, so we can take a t to the 6th out front. That'll leave 7 times sine for the first term. And if we take t to the 6th out here, we're left with a t times cosine. So that's our derivative using our product rule. So it was a derivative. At this point, we just simplify by taking out the common factor. Okay, here we have a quotient. So we're going to use the quotient rule. So we need u prime. So if we take the derivative of the top, the derivative of a constant is 0, minus 4 times the derivative of x, minus the derivative of x squared, so bring the 2 down, x to the 1 less power, and then v prime, the derivative of x squared, 2x to the 1 less power, and the derivative of a constant is 0. So for u prime, we get minus 4 minus 2x. For v prime, we get 2x. Remember, that's u prime v minus u v prime over the denominator squared. So u prime, it's all of that times v minus u. So it's all of that times v prime. All of that over the denominator squared. Now, we might be able to simplify this. We can do some algebra. We can distribute there, and we can distribute there, and we may have some like terms that we can combine. There's not going to be any need to multiply the bottom out. We may at some point be able to reduce with the bottom, but remember, when we reduce fractions, we reduce common factors. This is factored right now. We have this factor twice. If we multiply that out, it's not going to be in factored form. So if we distribute the top, we're going to have a minus 4x squared plus 24 minus 2x cubed plus 12x. So that's what we get when we distribute the first two parentheses. Minus 4x squared plus 24 minus 2x cubed plus 12x. We're going to subtract whatever we get when we distribute here. So 6x minus 8x to the second minus 2x to the third. Now notice we put parentheses around that because when we're subtracting, that subtraction applies to that whole parentheses, not just to the first term. So that parenthesis helps us just realize we have to distribute that negative after we multiply. So we have a minus 4x squared, a plus 24, minus 2x cubed, plus 12x, minus 6x, plus 8x to the second, plus 2x cubed. All of that's over the denominator. So let's see what we can do. So on top, our largest powers are to the third. We have a minus 2x cubed and a positive 2x cubed that cancel. Then we have some x squared. We have 8, and we're taking 4 away, so 4x squared. We have 12x minus x, so that's 6x. And then we have a plus 24. So that takes care of the x cubes. They're gone. We combine the x squareds. We combine the x's, and then the 24. All of that over the denominator. Now on top we have a common factor of 2 that we could take out. But if we try to factor the numerator anymore, that numerator is not going to factor. We're not going to be able to get a 2 out front, a 12 on the end, and a 3 in the middle. So that's as far as we can go, and that doesn't reduce. So some of the biggest things here, using parentheses, also recognizing that is a quotient, so we have to use the quotient rule.